Calorimetry. It measures the heat of a reaction. There are two types, endothermic, in which heat is gained by the reaction, think enter, and exothermic, which heat is lost by the reaction, think exit. Now, how do we measure this heat lost or gained? We use the calorimetric equation, which is Q equals mc delta T, which I like to call MCAT, not to be confused with the test that doctors take. So Q is the heat of reaction measured in units of energy. Mass is M. C is specific heat, which is the amount of energy required to raise a mass unit by 1 degree. And delta T is the change in temperature, more specifically, the final temperature minus the initial temperature. Notice how it can be positive or negative depending on whether or not the reaction is endothermic or exothermic. So I was purposely vague about the units for this equation because it can be any energy, mass, or temperature unit as long as they cancel out. But typically it's joules, grams, and degrees Celsius because that is the basic unit for specific heat. So that's what we'll be using. So mass and specific heat can never be negative. So the only thing that can influence the sign of Q is delta T. If Q is less than 0, it means that the temperature was released, there was less temperature, so it's exothermic. If Q is greater than 0, it means that energy in the form of heat is gained, which makes it endothermic. Now, we don't really like Q because Q is a path function, which means it depends on how you get to the destination, not just the start and end points, unlike state functions. But really cool thing about Q is that under constant pressure, it is equivalent to enthalpy, which is a state function. So only the initial and final conditions matter. So how do we solve for delta H in this equation? Simple, algebra. If all other variables are known, you just plug and chug and you get the answer. Now, what if two variables are unknown? Well, that's a little bit tricky, but here's where conservation of energy comes into play. Now, a reaction is something called a system, and anything not in the system is called the surroundings. Now, because of conservation of energy, all of the heat energy gained by a system is lost by the surroundings and vice versa. Lost by the system, gained by the surroundings. So we can sum it up saying that the enthalpy of the reaction is equal to negative the enthalpy of the surroundings for any equation. So how do we measure the enthalpy of a system? Well, we kind of don't. We measure the surroundings, but not the everything surroundings. We create a smaller system. So a system with surroundings and then everything else. And what will our surroundings be? Well, for our purposes, it's going to be water. Why? Because it is the universal solvent and things dissolve into it. And we know a lot of things about water. We know its density and its volume, because volume is really easy to measure, so that we can get the mass of the water. If you want to be that person and just use a scale, you can, instead of multiplying density by volume. We know the specific heat of water. It is 4.184 joules per grams degrees Celsius, and the temperature of water is really easy to measure as well. So, how will we do calorimetry at home? Well, we need 4 things. We need an insulated unit for the inner surroundings. So in our case, we'll use styrofoam cups and a lid. We need something to measure that, a thermometer. We need water, and we need the actual chemicals to form a reaction. We don't actually need the chemicals. We could just do calorimetry with only water, but who wants that? Another addition is that you can add a stir bar in there to make sure that the heat is evenly distributed throughout. the system. So our setup is this. We have 2 styrofoam cups stacked on top of each other with the removable cap on top and the thermometer sticking out so you can read it, hopefully. Inside you have the stir bar going so that the heat is evenly distributed, with the thermometer off to the side so it's not sucked in the vortex of the stir bar. Keep in mind that the reason that we do use styrofoam is because it is a pretty good insulator, because we do not want the outer surroundings, everything else, to interfere with the temperature change inside. But you can use anything else, just be aware that that is a problem because heat is lost to the outer surroundings. Now, what do? Well, after we have the water in, we put chemical 1 in, and we wait for the temperature to stabilize, because the temperature will change because things dissolve in water. Then, after the temperature is stabilized, we put in chemical 2. Then we measure the change in temperature. If the temperature goes up, it's an exothermic reaction, and if the temperature goes down, it's an endothermic reaction, because remember, we're measuring the surroundings, which is opposite. Now, if we want to be a little bit more precise with MCAT, it's going to take a bit more work. You have to measure past the local maximum or minimum temperature and find the exact time that the second chemical was added. Then you need to account for all of the heat loss to the outer surroundings, because it will be lost. And what you do is you do the thing that I just said with only water. You find the Q's or delta H's of the hot water and cold water mixed together. So you'll have the final temperature will be the same. Then you add them together. The hot water will be negative. The cold water will be positive. Then you take the absolute value of that sum, divide it by the change in temperature of the cold water. Boom, pow, you get the energy lost per degree Celsius for that. Now, why is this thing important? Well, it's nice to know the energy change of things. Engineers can use it to be more efficient, or that. It's also used in everyday life, like cold packs are just 2 chemicals that have an endothermic reaction and make things cold. Why else is it needed? Well, specific heat, C, is unique to each material. So if you're working with something unknown, just find the C and you'll be able to look up a reference sheet to find out what it is you're looking for. Or if it's a totally new material, you'll be able to know what properties it possesses in regards to temperature and energy. Now, if you do this at home, stay safe, wear protective gear, long pants, closed-toed shoes, put your hair up, if applicable, wear goggles and gloves. And if you are working with chemicals, look up the name along with SDS, which stands for Safety Data Sheet, which will tell you if the chemical is dangerous, how to handle it, and how to properly dispose of it. Okay, have fun.